Hey, welcome to part 4 of measurement. And here we're going to do something a little bit odd. We're going to make our own equation. See, here's the deal. As scientists and everyone, when you're doing something, you're out in the world, you're doing something, there's a very good chance you are doing something that has literally never been done before. If it had been done before, it wouldn't need doing. Well, that may very well mean that you have to create your equations. You don't get to take a canned equation and plug it in and chug out a number because no one's done it before. You have to do it because you're the one that gets to do it first. Well, here's how we're going to do that. And a lot of the time, especially in chemistry, we're changing the units. Now, we might be changing the units from, say, feet to meters or centimeters to meters or something fairly straightforward, what we normally think of as unit conversion. But quite often, we're doing unit conversion between units that don't seem to have that much to do with each other. So we could imagine, converting cups of coffee to kilograms CO2 released. And you're like, what? Huh? What? Well, it takes a certain amount of energy to grow the coffee, to purify the water, to boil the water, to grind the coffee, to squirt the hot water through the coffee to make your cup of coffee. That energy was probably produced with fossil fuels because that makes up a very large proportion of our power grid. And once those fossil fuels were burned, that released carbon dioxide. It's basically just a math conversion. It's a really convoluted one, but it is just a math conversion. So we're going to use what's known as dimensional analysis to give us a structure for how to do these crazy conversions, whether it be simply feet to meters, something you can look up online, or cups of coffee to kilograms of CO2 released, which is going to take a lot more work. With dimensional analysis, what we're going to do is we're going to first look at our question. Here's a nice simple one. Feet is how many inches? Or 2 feet is how many inches? We're going to need to know some information. And what we need to know is the equality. The equality is a true statement that blank is blank. So 1 foot is 12 inches. And that's definition, so it's going to be an exact number. But we're not going to bother tracking sig figs for this little bit. We will, of course, later on. So don't use that as an excuse of why you have 2,000 sig figs on your exam. It will lose points. But we're going to change it from English, we're going to change it into math. So the word is synonymous with an equal sign. So we're just going to turn it into an equal sign, and now we have an algebraic expression. Sort of. Almost. We're going to turn that equality. So this number turns into a conversion factor, because this equals that. If you take a thing and divide it by itself, it equals 1. That means that this equals 1. That also equals 1. Here's the beauty. To any equation, you can multiply it by 1. You haven't done anything. Well, that means I can create conversion factors that allow me to multiply my 2 feet by the conversion factor. I haven't mathematically changed anything because the conversion factor is only 1. But now I've changed my units. I haven't changed well, the values do change, but the number itself, if you think of the value and the unit together, hasn't really changed. It's just changed forms. Now, I will always have 2 conversion factors when I do this. Any equality could be the one on the right put on top and the one on the left put on the bottom, or vice versa. Well, one of them is going to work and one of them is going to give me nonsense. I want to pick the one that works, not the one that gives me nonsense. So I'm going to take what I know and then I'm going to multiply that by my conversion factor, but I have to pick the right one. What I want to pick is what you want by what you got. So essentially what's going to happen, remember these guys behave a lot like variables. If I divide a unit by itself, then it's going to cancel. Well, if I take the unit I already have and I make sure it's on the bottom of the fraction bar, then it will cancel, assuming the unit originally is on top. Obviously, if it's switched, then the whole thing switched. And then whatever unit's on top of the fraction bar will persist. Once again, assuming everything's right side up. So I pick what I want, inches, divided by what I got, feet. The feet cancel, and I'm left with inches. Yay! And I can run the math. I get 24 inches. Wonderful. Now, that's a one-stepper. That's fairly straightforward. We're going to move beyond that pretty quickly because that's kind of dull. Okay, so I'm going to take 2 feet is blank centimeters. So I'm going to need some conversion factors. And in fact, I'm going to need 2 equalities for this. I'm going to need feet to inches because I don't happen to have one that's feet to centimeters. If I had feet to centimeters, I could just do feet to centimeters. But instead, I'm going to do feet to inches and then inches to centimeters. By the way, both of those are definitions. The inches to centimeters is actually a definition. That's how the inch is defined. I'll convert that into math because yay, math. And now I'm going to have my conversion factors. Once again, I've got 2 of them. Now I've got 2 of them for each one, and then so I've got a total of 4. I'm going to get to pick 2. I'm going to put them in kind of order right now. So what I want by what I got, well, what I got is feet, so feet's going to go on the bottom. What I want is centimeters, so centimeters is going to go top. Oh, look, the inches on top on one, inches bottom on the other. Yay! Okay, so now I'm going to start working the math. I'm going to have what I know, going to multiply it by what I want over what I got. What I got is feet. Now, I don't want inches, but I want it now as an intermediate. Now my feet go away. Now I'm left with inches, 24 apparently. But there's no reason to type it into the calculator yet. To just do the whole thing at once. Okay, now I've got inches. I don't want inches, so what I want is centimeters. So centimeters divided by inches. Inches are going to cancel. Yay. This canceling pattern tells you you're on the right track. If things don't cancel, you've probably got a conversion factor upside down. Incredibly easy mistake to make. So just go make sure your units cancel and you get what you want. If you get some bonkers unit at the end, you probably got a conversion factor upside down. Once again, easy mistake to make. Okay, so I get a number, and then I want to go through and round that thing. I've only got one lousy sig fig on that 2 feet, so I get to round to one lousy sig fig, so 60 centimeters. Yay! By the way, there is a slightly different method. This is the line method or line mole method. It's a little bit faster, a little bit more casual, but it works fine. Engineers usually use this a little bit more. You're welcome to use whatever you want. So it's going to do exactly the same thing, but instead of doing number, fraction, bar, number, multiplication, fraction, bar, multiplication, fraction, bar, yada, yada, you just draw one ginormous fraction bar. And you're right, whatever your first number is, on top of it over to the left-hand side. Traditionally, and this is, I believe, in exact opposite of the way the mathematicians do this, we start with the thing you know, what's not the conversion factor. We stick that on the left-hand side. Makes it easy to sort out things. Then you draw a line. That line is essentially acting as a time sign, separating out each of your conversion factors. Now, there's nothing below the 2 feet. You can have something with just a blank there. That's perfectly fine. So I've got a first conversion factor. Once again, same what I want by what I got. 2 feet, or sorry, 12 inches over 1 foot. The feet will cancel. But right now I'm going to go ahead. I'm going to drop the next bar. I can't call those a railroad track. I don't know why I called it a railroad track, but I like to call it a railroad track. And I go for the next conversion factor. And once again, I can just keep going. I mean, I'll do one of these things that might have half a dozen more different conversion factors. You just add in one more on the other. It's like, how do you cut down a forest? One tree at a time. I don't know why you're cutting down a forest, but if you do, it's one tree at a time. Okay, look, I make sure everything cancels. Feet cancels with feet, inches cancel with inches. I'm left with centimeters. I'm good to go. That's once again going to equal 60.96 centimeters, but I only got one lousy sig fig to start with. The 12 inches over 1 foot, that's exact, both of those. The 22.54 centimeters per 1 inch, that's also exact, so ignoring that. So it's going to go for 1 sig fig from the 2 foot, so I round to 60 centimeters. Yay! That's the core of what we call dimensional analysis. We are looking at the dimensions, the units themselves. We're using that to create our equations. Because once again, we're doing stuff that have never been done before. If it had been done before, why would we do it? Well, last up on measurement, we are going to start talking a little bit about a compound unit density. And so I'll see you for part 5. Have a good day.